Having discussed this example previously, these are the things that we discussed inside the uploaded lecture. Moving to the second example. So what we're doing is we're still using the first table, the amount of laborers. But all that we're doing now is saying, okay, you have EU has 200 population or 200 laborers. Kenya has 120. What does that mean in terms of how much food I can produce with 200 laborers, how much chemicals I can produce with 200 laborers, and similarly for Kenya for the 120 laborers. So I put the table here, so it's easy to see the calculation. 200 laborers, it takes 2 laborers to produce 1 food in the EU. So 200 laborers would be able to produce 100. 200 divided by 2 gives you 100. Similarly speaking, if they didn't produce food and you said, okay, what happens if these 200 laborers produce chemicals only? How many chemicals would I be able to produce? It takes 8 laborers to produce 1 chemical. We have 200 laborers. That means you can produce 25 chemicals maximum for the EU. 200 divided by. Similarly, you do the same calculation for Kenya. 120 divided by 4 gives you 30. 120 divided by 24 is 5. So now you can draw your PPCs. Also, you can also work out what is your terms of trade or for your cost for chemicals. The cost for 1 chemical or to forgo. If you want to produce 25 chemicals, what do you have to give up? 100 food. If you want to produce 5 chemicals for Kenya, you have to give up 30 food. So you can actually work out the terms of trade now using this chart, the maximum food and the maximum chemical chart, rather than this table of laborers, which required a bit of thinking. So easy speaking, when you're dealing with the terms of trade and you have the maximum food or chemical that you can produce based on the labor and this laborer chart, all you have to do is to work out the terms of trade for carbon. So terms of trade for EU with respect of chemicals would just be food over chemicals. This is a bit different from this table. In this table, when you wanted to work out the terms of trade, it was the other 2 liters an hour. But once you take into consideration the maximums, it's easy to do this way. So that's 100 food you must sacrifice to produce those 25 chemicals. And that would give us 4. So that means 4 food have to be given up to produce 1 carbon. That's the terms of trade for carbon. You can do then similarly the terms of trade for Kenya in terms of carbon. So in terms for Kenya, terms of trade would be as simple as taking 30 divided by 5, and that would be 6. Same values we're getting as earlier, right? That's when they give you this table, the maximum food and chemicals you can produce based on the total labor. And then you can do the terms of trade in terms of food and the terms of trade in terms of, for both EU and the Kenya, the terms of trade in terms of food. So this is not what we exactly doing here. We want to draw this information. So we want to draw PPCs. We need the terms of trade. So remember the terms of trade, just for interest sake, I'm going to put it here on the side. So in terms of carbon, terms of carbon. For the EU, the terms of trade was, in terms of food, just in case, terms of trade in terms of carbon for the EU was four food needed to produce 1 carbon, and it would have been 6 food needed to produce 1 carbon for Kenya. In terms of food, the terms of trade to produce 1 food year would have been 1/4. A quarter carbon must be given up to produce 1 food, and over here it would have been 1/6. A 6 carbon must be given up to produce 1 food. This, we might need this later. So let's draw the PPCs. Remember what our start here and our assumption is. We are busy with autarky first. We're looking at each country separately before they open themselves up for trade, for international trade. And another assumption we need to also discuss is the idea that under autarky or under any scenario, both these countries want to consume food and carbon. They don't only want to consume one item. They want to consume both items. Okay, so let's just draw the PPC in. So it's up to you on what you want to put in terms of the margins and that. Let's put chemicals here. So it's similar to the textbook. And we put food here. And we look in terms of Kenya. So the maximum food that we could produce in Kenya was 30. And the maximum chemicals that we could produce in Kenya was 5. Just randomly putting values there, huh? So we draw that line in. This here is 30. This here is 5. Okay, that's for Kenya. So what is the terms of trade in terms of Kenyan pickles here? 6, right? This is for Kenya in terms of trade. Here is 6. These are terms of trade. And that is 6 food for 1 chemical. Okay. So let's say hypothetically we're trying to find, okay, this is the PPC, this is what they can produce. They can either produce 30 food or they can produce 5 chemical or anywhere else in between, right? The problem now lies is what is the prices in the society. This also brings you to another problem with this model. Another problem with the Ricardo model, it never ever discusses anything from a demand side. It only discusses things from a production side. So there's no demand at all taken into consideration here. Let's say, for instance, the terms of trade was 7 food. 7 food you would get if you produce 1 carbon. So previously speaking, to sacrifice or the cost of 1 carbon was 6 foods. Now they're telling you it's 7 foods for 1 carbon. So the price of carbon has gone up. It's taking you a lot more food to produce 1 carbon. What happens in terms of production? Can the price be that in terms of production? More so than what the normal terms of trade is in the market. When anything goes up in price and a producer sees that there's more profitability in there, what do they want to do? They want to shift all production towards the item that's going to give them the most profitability. So in this case, all production is going to shift to carbon. So we're just going to produce carbon entirely because it means when we trade this carbon, we can get 7 food. And it's only taking us to sacrifice 6 food to produce this 1 carbon. Now, when we sell it, we will get 7 foods. And that is enticing. It says, okay, I stop my production. Normally speaking, it's 6 food to 1 carbon. I'm sacrificing 6 food to produce this 1 carbon. Then I can sell it in the market inside Kenya for 7 foods. Then I'm definitely gonna go in and produce entirely carbon because that's where the money is. So I take the 7 foods and that I can get for carbon. Why not? Why wouldn't I take it? What's the problem? What is the assumption I told you? In this country, or in any country, they want to consume food and carbon. When the price is at 7 foods per carbon, more than what normally would be, all production is moving towards chemicals or carbon. And that can't be. That means there's no food production. So this means this price cannot hold. It will not exist in the society. So let me assume now the prices are for food per carbon. What happens now? What has got more expensive? Firstly, speaking, remember whenever we're dealing with two products and the one is getting more expensive, then that means on the other side the other one is getting more cheaper. So if something is getting more cheaper, then it means on the other side something is getting more expensive. So what happened now? Previously speaking, it takes you under normal production process 6 food you have to sacrifice to produce 1 carbon. Having done that, you take the 6 food and produce 1 carbon. The world price now, or the price inside Kenya, is 4 foods for 1 carbon. Why would you give up 6 food to produce 1 carbon, but then you can only get 4 food back in terms of what the economy is allowing you? You wouldn't do that. It doesn't make sense. That means the price of carbon is cheaper than it had been under a normal scenario if we had done according to what production was saying. So what does that mean? If carbon's getting cheaper, what does it mean in terms of food? It means food is getting expensive. Right? If effectively it means the cost of food here is 1/6. If you look at the reverse, 1/6. And now the cost of food here is 1/4, a quarter. So the cost of food has gone up. And if there's more profitability and food has become more expensive, where are you shifting your production to? You're going to shift all your production in terms of food. That means you're only producing food. Is that possible? Under the assumption you need to consume food and chemicals. No worries. So at the price of 4F per 1 carbon, all production shifting towards food, it would never hold because you will not be able to produce any carbon. So therefore, based on what we established now, any price more than 6 food per carbon or any price less than 6 food per carbon would result in only one product being produced where you want both products produced because you're living under autarky. There's no trade happening outside the world. So the government cannot set these prices based on what you are paying for production. So that means that the price that must exist in this world based on what the production prices must be exactly the same. The only price it will hold is 6 food per 1 carbon. Anything else would never hold. So this is the dilemma we sit on. So what does that mean? That means a pricing line or terms of trade line will lie exactly on our PPC. So it will be exactly on it. And I don't know how to draw that unless I take a different color. So both lines will coincide with each other. Will be both exactly on terms of on top of each other. Okay. So let's move on to the EU, still under autarky. If we had drawn the EU line, same axis, we're not changing the axis. We're still having carbon here. We're still having food here. What is the maximum carbon they can? This is for the EU. The maximum carbon they can produce is 25, and the maximum food they can produce is 100. So somewhere here, and then we assume here. Value here is 100. Value here is 25. So effectively, in terms of production, or your opportunity cost here, or your terms of trade here, would be 100 divided by 25, which is equal to 4. So that's 4 food per carbon, per 1 carbon. And we now discuss the same type of thing I discussed for Kenya. What if the price was 5? If the price was 5, it means carbon would have gotten more expensive, meaning all production will shift towards carbon, meaning no food will be produced. And similarly speaking, then what if the price was, if the government said the price is 3 food per carbon, that means carbon would become cheaper, and effectively that means food will become more expensive, and then all production will shift towards food because there's the increased profitability there. And if only food is produced and no carbon is produced, that cannot exist in society because we need both food and carbon to be produced in society based on the earlier assumption. So therefore, that means because the prices can neither be higher than 4 or less than 4, the terms of trade will be exactly the same as, or the pricing will be exactly the same as the production. That reduction side, which means again we would have a line coinciding with each other. And that's under autarky. So the next part of this discussion is going to go to the idea of what happens when we open ourselves up. When Kenya and EU tries to trade with each other, what would be the most ideal price that could exist between the two?